Hi everyone, this is Aaron Ruck, and today what we're going to do is we're going to go over how to use the Shop Mill Programming function on our fryer mills. This is how we're going to work towards getting our final stage in getting our Siemens certification. So what we're going to be doing is we're going to open up our mill, and it will just take a second to load. The first thing I want to get out of the way is to make this a little bit quicker. I have gone in and I have created my tools. I have created a tool 1, tool 2, 3, 4, 5, and I have the diameters right here. So if you don't have this set up such as this, it's fine. Just make sure that you have it set up before you start programming. And if you have them labeled as different tool numbers, that is also just fine as well. Just make sure that whenever you go to start picking everything that you do have them picked as the correct items. Like, don't try to end mill with the drill because it will do what you tell it to do. Also, another thing to help with the simulation, if you look at the work offsets, you'll notice how all these links are 0. If I go in the work offsets, you'll notice I did put a minus 10 inches. I'm going to take these out. I'll show you why those are important later. And with that said, I'm going to go right back to my program manager because we are ready to start programming. Now remember, this is a shop mill, so this is a Siemens hand programmed program that we're going to be using. So the first thing I'm going to do is I want to create a new folder, and we'll call this, the name of my print is 8M, and we'll say OK. Now if I look at my print, this is what we're going to be hand programming. So on 8M is what we're using, that's why I called it that. We got several things we want to look at. The first thing we're going to do is we're going to build that material. So if you'll note, I have 4" by 4" by ½ inch material, and then the top of it is going to be minimum cleanup. So this is what my part's going to look like right here, except if you'll notice right here on the front edge, I'm going to need to cut into the part right here and on the side because that's what I want it to look like when it's completely done. Because I want to make sure that all surfaces are machined. So back to my simulator. So if you'll notice, this did open up my material to make. I'm going to click on Graphics View. I'm going to deselect it. I'm going to put these to 0 because it'll make sense a little bit later as to what's going on with those. But the first thing I want to show you is whenever I'm creating my block of material, I want to start off at X0 and Y0. This is going to be 4 inches. That's going to be 4 inches, just like my print said. And then the top of my part is Z0, and the thickness of my part going down is going to be a ½ inch. Now if you put that as a positive ½ inch, that means that it's going to build it this way, which means your simulation is not going to look correctly. So I'll hit enter. We are going to be using the G17. Retraction plane of 1 inch. Safety distance plane is going to be 100 thousandths. We are going to be machining into the part, and we are going to use a retract position before going into a new location. So with all that said, I'll hit accept. And the first thing I want to do, if I go back to my print, is I want to go ahead and I want to face my part. And then after I face it, we'll go ahead and start working on the profile. So we'll go back to my simulator, and then I'm just going to go up to milling. The first thing I want to do is a face mill. Now when I click on these, a lot of this stuff is already going to be filled out. Whenever you open up yours, there's going to be a lot of default settings in here, so I will go through them as if it was set to default. So for this first tool, I'm going to hit select tool, and I want my facing tool to be what I'm using, so I'll hit OK. I'll arrow down and I'll put that at 50 inches a minute. 3,000 RPM sounds pretty good. Now right here, if you'll notice, that says finishing. Now if you have a lot of material to take off, you can do a roughing and have it step down so far. However, we are just milling to minimum cleanup, so a finishing pass will be just fine. Right here you can control how the tool paths look. So the first one that comes up will work just fine, and then I'll arrow down. So right here, for the center points in X and Y, I usually don't change anything. For the Z0, I don't change anything. I let it know that the furthest point in X is 4, just like when we were setting up the material, and the furthest point in Y is also 4 inches. If you'll notice, this will probably come up 0, and these will be red. So for example, you would see something like that. Well, with Z0 being the top of my part, for simulation purposes, I'm just going to make that 5,000. So you notice that does go back to white because the machine doesn't have any logic interference. It'll be doing a 65,000 step over or 65% step over. and I'll leave everything right there. So finishing allowance, I'm not worried about it because I'm going to finish it all at one time. I will hit accept, and the first thing I want to do after I complete anything during this programming is I just want to simply simulate it. So when it comes up, you'll see the part will come up in a top view. If you want to, you can click 3D view, and if you hold your left mouse, you can pan your part around. For your roller, you can zoom in and zoom out, and your third mouse will rotate your part. So you can do with that as you please. I usually like to go into 3D view. When you're done with your 3D view, simply hit simulation again. So with that said, it's looking pretty good. So if you haven't printed off this print, now would be a good time to do so, or ask for the print, because I'll be going through it a little bit quickly. I won't be coming back and forth as much, but just in case, if it helps you with keeping track and keeping up. So the first thing I'm going to do is I'm going to make this profile. I'm going to start at this location, and then I'm going to go step by step all the way around my profile. I'm actually going to tell the machine what each pivot point is all the way until my profile is closed. So back to my simulator, I'm going to go into contour milling, and I'm going to create a new contour. And we're just going to call this a boss because that's what it is. And then I usually don't worry about the views for here. It's just going to let me know that my starting point is XY0. I will hit start. If you'll notice, I am at the bottom left corner. That's my 0 and that's my 0. First thing I want to do from that position is I want to go up in Y 3 inches 937 thousandths. And then I'll simply hit accept. So if you'll notice, it put me up that high, and that's how we're going to do this all the way across. So this next point, we'll go 3 inches 937 thousandths. But if you'll notice, there is a radius there. So this is what's cool about hand programming on a simulator, is I can subtract 1 inch 181 thousandths and hit enter. And then when I go to accept it, you'll see that it did stop it short of the amount that it needed to be stopped. It went to 3 inches 937 thousandths and then subtracted 1 inch 181 thousandths, which gives me this current location. I like that, so I'll hit accept. From here, I'm going to be doing a radius. Now, if you'll notice that this is not the radius I want to, that would be a counterclockwise, and I want to go a clockwise direction. So simply click on this, select the right location, and I'm going to do this a certain way. There's more than one way to do it. This is just the first way I'm showing you guys, and I find it to be the easiest for what we're doing. I'm going to come right here and I'm going to say 3 inches 937 thousandths is where I'm going to end at. Right here is going to be 3 inches 937 thousandths. Again, I'm going to subtract the radius and then hit enter. Now nothing's going to show up until I hit that right there. I'll click on graphics view. That way it will show me that it does this radius. Now until I hit that, it just puts my location right there. That's my end location. But by hitting my tangent, it swings that radius the correct direction to the correct position. So I'll hit accept, and I'm going to move down. Again, I'm going to move to 984 thousandths plus that radius of 312 thousandths. I'll hit enter. So from here, I want to do another radius. Go the right direction. I'm going to type in my endpoints. My endpoint X is going to be 3 inches 937 thousandths minus 312. Now this will be 984 thousandths. And then when I hit tangent, it does swing it. And now from here, I'm going to go 1 inch 969 thousandths plus 0.312 thousandths. Enter. Hit accept. And now this time, whenever I swing it, it is going the right direction. So I will simply put in there the 1 inch 969 thousandths, and then the Y will be 984 thousandths subtract 312 thousandths, and you'll see it puts my endpoint right there, and when I hit tangent, it does swing it all the way down. And then from here, I'm just going to go back to Y0 and X0. And if you'll notice, this has done my entire profile. So from here, I'm going to hit accept because I have finished my boss. Now that I have a contour, I want to go ahead and create tool path. So path milling, I'm going to be using a tool, so I'll select tool number 2, which is a 1/2 inch end mill. And then I'll come down, 50 inches a minute looks just fine. 4,000 RPM sounds good. Now right here, notice how it does have the finishing symbol. I want to use for roughing. I do want to be going forward. Now keep an eye out for this right here. This radius compensation is to the left of the line. You have several different options. I'm doing the profile, but if I wanted to cut on the inside of the line, I would select that right there. So by default, it comes up using this symbol, which will cut on the left side of the line. So my Z0 is the top of my part. My depth of my profile, if we come back and look at it, says 150 thousandths deep. And then I want to take 50 thousandths depth of cut each time. I'm not worried about leaving anything for the finish allowance. In Z, now on the plane for leaving finish allowance on the sides, I'm going to go ahead and leave 10 thousandths. That way it gives me a nice finish cut, which is really easy to program because we have this ability. So I've got an approach point. Now keep in mind, this approach point means it's going to start 500 thousandths off to the left, and then when it retracts, it's going to come off again 500 thousandths off to the left, okay? Or down, possibly, whichever one that default selects right here. Now keep in mind that this will have to be changed later on, and I'll show you why. It won't have to be changed in this path, but it'll be changed in something else. So before I do anything, I want to go ahead and hit path milling again. All I'm going to do is change this to finishing. I want this to take everything out on one pass, and then I'll just simply hit accept. Very cool. I'm going to use the same tool, feed rate, RPMs. That's all it's going to do is take off that 10 thousandths that we left on that previous function. So I have a roughing and a finishing, and now that I have completed the boss, I'm going to simulate. Now of course it will simulate the face, and then it will start simulating that boss. One thing I want to point out is that it does look just like the blueprint. It is not cutting on these sides. However, I must have machined surfaces all the way around the part, and I'll show you why what that's going to look like here in a minute. So I'll move that back to the middle. I'll turn off simulation. Now if you noticed, I'll turn this on one more time so I can point out what I'm looking at. If you look right here, I have some material that's been left over from that end mill and a big chunk of material right there, and I'm going to call that excess. So I need to make toolpath that will get rid of this excess material. So click off of simulation. I want to go to contour milling. I'm going to make a new contour, and then I'm going to simply select excess. We'll call it that right there. So notice how it wants to start right there at the bottom left. However, I don't want to come down at the bottom. I'm going to tell it, looking at our blueprint, I'm going to tell it to come to X 4 inches, and I want it to be down right here because I don't want it to come down on top of the part. The goal is for my toolpath to come up, over again, and I want to come far enough because I'm going to move up here to click that off. And I'm going to come up, and I'm going to just put my tool right over the top of that right there. By doing that, my tool by default will take that off. So we'll come back to our sinew train. And then my starting location is going to be 4 inches. And I want to start a -1/2 inch right there. So that way I know my tool will be completely off the part, and I'll hit accept. So now that I have my starting location, there's my home. There's my starting location for this new profile that I'm doing, the new contour. I'm simply going to move up, and it's up to you to figure out the numbers. I'll let you figure it out. I'm going to come up to 300 thousandths, and then I'll hit OK. And now here's something that's cool. Usually what I do is I'll type in these locations because they are known locations, and then I'll subtract half the diameter of my tool, or a little more. That way it puts me in a good spot. That way there's no guessing. I know what's happening. So again, I'm going to come over 1 inch, 969 thousandths, plus I know 250 thousandths is half the diameter of my tool, so I'll go 300 thousandths. So that way I'm 50 thousandths away from actually cutting that profile that I just made. That might sound confusing right now. It will make a little bit more sense later on. So the same thing, I've got 984 thousandths minus 300 thousandths. I'll hit OK. And now I want to clear all the way off the part, which is going to be 4 inches, 500 thousandths. I'll move up to 4 inches like we said. And then I'm simply going to move over to 4 inches as well. And hit OK. So now that I have a contour, I'm going to do a path mill. I'm not going to do a finishing on here, but I do want to go 50 thousandths depth of cut each time because I'm just cutting off excess. There's no need to have a finishing pass, but I'm going to do 50 thousandths levels, and I'm going to hit OK. Now, remember that symbol I told you about. We're not going to change anything right now. I want you to see what it looks like if I don't change that symbol. I'll hit accept, and we will simulate. Again, the first thing it will do my facing. And then it's going to do my finished pass. If you notice right there, it's cutting way far into the part. Now, it's doing that because I told it to cut on the left side of the line. So by doing that, it goes further than what it's supposed to. This is an easy fix. I will go back to what I'm doing. I can either hit the right arrow on my keyboard or I can click on it. I didn't cover that earlier. But now I don't want it to stay on the left side of the line. I want to do center line programming. So I'll select that. I'll hit accept. So this time it will not be cutting on either side of the line. It will be cutting exactly where I told it to go. So it's going to do its finished pass. And just like that, it's cut it all away. But if you'll notice, it did two more things. It did not cut everything right there, and it did cut into my profile. So we got one more thing to look at. So I'll hit simulation again. And what that meant was on this contour, this first move, now what I'm going to do is I'm going to arrow up to each point of the contour. And that first move of 300 thousandths. Now remember, it's a half-inch tool, so 250 thousandths is half the diameter of the tool. So if I move 300 thousandths, that means that that lip that we left right there was 50 thousandths thick. So easy fix. I'm going to come in here and also make that 250 thousandths. If you wanted to, you can make it 200. You can make it anything less than 250 thousandths, and that would work just fine. Okay, so that looks really good. Now the next thing I want to point out is it cut the top of this profile right here. Now remember I told you about that approach and retract. So what's happening is it's completing the move, but then for the retract out, it's moving an additional ½ inch to the left. So all I'm going to do is make that a 0, hit accept, and let's simulate one more time. When you are making your parts, you will run into a lot of miscellaneous functions or miscellaneous errors. The key to it is just understanding how everything works on your simulator. That will help you define your profile and get everything working just fine. Alright, so that looks really good. It's not cutting into it. Now the next thing I told you is that I want to cut all the way around the profile. So I need it to cut into here. So on my setup, I usually tell people to go in about 30 thousandths on both sides. That way I can keep 30 thousandths clean up over here and over here, so it keeps everything nice and even. But to do that, I'm already pretty far into my programming. So I'm going to come all the way back up here to my block header, and what I'm going to do is I'm going to move my material down and to the left of the starting point. So keep in mind, this location right here, this corner, I have it programmed to X0. So what I'm doing is imagine that profile being inside here. I am moving this block of material down and to the left of that starting point. So I'm going to hit accept, and I'm going to simulate one more time, and you'll see what that does. So now that you see, the profile has not changed. My paths have not changed. And it cuts on both sides right here. But remember I told you, if I just went 250 thousandths, that it's going to leave anything else. So that is a 30 thousandths lip. So I'll come back to my simulation, and that very first line of 250, we'll make that 200 thousandths. And again, anytime I change something, I want to simulate it. This will help prevent frustration later on in the program if you get everything right step by step. So again, I am cleaning up right here. My excess now takes off everything on the top and bottom. Now, the reason why I have so many of these errors in here is because I want you to see what an error looks like, and I want you to know how to fix it and see that it doesn't take very long to fix it. So we're done with the profile and the facing, and we're not that far into it. So what I'll do is I'll move my cursor where I want it to be, and I'm going to make a pocket. So from here, I'm going to click Milling, Pocket, and then I've got this square right here, but I need to put it in the right location. So again, we're going to go to Simple, we're going to select the tool. It's going to be tool number 3, which is our 3/8 end mill. And 30 inches per minute looks good, 600 or 6,000 looks good, and I'm going to change this to a roughing. So the first thing it wants me to do is put in those locations. So this location is going to be 1 inch, 377 thousandths, and on the next one it's going to be 2 inches, 755 thousandths, and that has my location. And then from there, I'm going to put in that my wall, put that at 0, because that's the top of my part. Now the width of this pocket is right here at 1 inch, 968 thousandths and 5/10. So we'll type that in because that is the length and the width. So I'll type that in, 1 inch, 968 thousandths and 5/10, and again 1 inch, 968 thousandths and 5/10. So now you can see on the screen it looks really good. It actually positions it where it should be with the graphics view selected. So from here, I want to tell it how far deep to go. Okay, I have a radius on there, but I'm going to come back to that in a second. So I want this to be minus 196 thousandths, because if I look at my print, that's how deep the pocket is. Now also on the pocket, I can put a radius on all 4 sides, and in this case it's going to be 312 thousandths. So if I click on the radius, 12 thousandths right there. So now I have my positioning, my length and my width, my radiuses, and my depth. So from here, you'll see that I'm taking off 40% of the cutter on the step overs. I'm going down 50 thousandths depth of cut for each pocket pass. I'm going to leave 20 thousandths along the walls, and I'm going to leave 2 thousandths on the floor. Now here's where you can have some fun if you want. I've got a vertical zigzag, I've got a helical zigzag, and I've got this last one. I'll let you guys look at that and see what you think about it. But I'm going to use the helical. I've got 2 on my inches per revolution on the, it will say what it is, on the pitch, and then I've got 100 thousandths on the helix radius. Okay, so I'm going to hit accept and simulate. Now of course, unless you've changed anything, your facing and your profile should all come out looking just fine. I'll make sure that I am still profiling around the outside. I'm cleaning off the excess, and now my pocket will start. And that is a 50 thousandths depth of cut each time, so it will do it 4 times. Should be number 3. And on the 4th one, right there. So now you got to remember, pocket's not done yet because we just roughed it out. So I'll click on simulation. I'll simply come back to rectangle, and then I'll click on here and I'll click finish. Now when I click on finish, all I'm going to do is hit accept, and now these two are tied together. So I'll hit simulate. And if you want to, you're always more than welcome to speed up your simulation. I've got it at 115%. If I go to 120, it will go so fast that we can't see what's happening. So I've got my first pocket depth. Should have the second. And then I've got my 4th pocket depth. And then I've got my finished pocket depth. And on the finished pocket depth, you can make it go 50 thousandths at a time, or you can go ahead and just make it do all of it at once. So that was my rough and finished pocket. And now I have left, if we look at our print, is I'm just going to do these holes. Now these holes, when I make them, kind of look funny, but it's going to work out really easy. So I'm going to hit simulation because I'm done. And then I'm going to come up here to drilling. Now the first thing I want to do is make a centering drill. I'm going to select tool number 4, which is my center drill. Now you have two ways of doing this. You can click on diameter or you can click on tip. I usually like to click diameter, and then I tell it to make the diameter smaller than what the hole is. So if we look at our print, it says the diameter is 125 thousandths. So anything smaller than that is going to work out just fine. If you want the centering drill to chamfer the hole, you can always make that bigger, so that way the holes at the top of it will have a countersink. So, but for this case, I'm just going to make it 50 thousandths. And then I've got right here is the dwell time. I just leave it as default, and I hit accept. That's done, but I'm not going to hit my pattern yet. I'm going to set up my drill. So on my drill, I'm going to select my tool, which is going to be tool number 5. And then I'm going to come down to inches per minute. I'll leave it at 20. At 2,000. Now it has right here, it has shank and tip. So what that means is how deep the hole is going to go. So if I leave it at tip, let's put this at a minus 300 thousandths, and then we'll look at this real quick. So if you'll see, the tip is right at 300 thousandths negative. But if I change it to shank, you'll see the diameter of the hole is 300 thousandths deep. If I look at my blueprint, it says it wants the diameter to be 125 thousandths, diameter 196 deep. So it wants that diameter that deep. So in this case, I will be going with the shank and not the tip. And it did say a minus 196 thousandths. So I've got my center drill, I've got my drill. If you'll notice, the shank of it is almost at 200 thousandths, it's just shy. And then I'm going to hit accept. At this point, I've got a center drill and a drill. Now I can tell it how I want to do it. So I'll go to positions. I have different ways I can do it. I'm going to select this one right here, which is my bolt hole circle. Now I did have this default setted, so I'll go ahead and go through what it means. So I've got this Z position right here. Now this is not the top of the part. This negative 196 thousandths is how deep it is from the top of the part to the bottom of the pocket. Now if I make it 196 thousandths deep, there is a chance that the tip of my drill is going to go across the top of my part. But if you remember at the very beginning, there is a retract plane of 100 thousandths. So you do want to program it right to negative 196 thousandths. So don't think that you're going to scratch across the top, because we have set it up with that clear plane or that retract amount, so it will clear. So that might sound like a lot, but all I'm trying to say is program it exactly the way it shows on your print. So the center is going to be the same location of the pocket center. It's going to be 1 inch, 377 thousandths in X, 2 inches, 755 thousandths in Y. I have a 45-degree angle, and the radius is from the center to the center. That's 787 thousandths. Which is put right there, and then I have the number of holes, which is going to be 8. Right here on positioning straight, I usually leave it straight because it's just how it goes from one hole to the next. I'll hit accept. Really easy to set up. I have no red anywhere on my screen. I will simulate and see what it looks like. So once this gets done simulating, if everything looks the way we want it to look, then in not very much time, we have gone through and we have generated a toolpath for our facing, our boss, our pocketing. Also, we generated a toolpath for getting rid of the excess material that was left from our boss. And we also got our drilling. So if we watch this, after the finishing passes on the pocket, it should come in and it should do our spot drilling, so just 50 thousandths diameter, and then it comes through and it will drill all the way in there. So with that said, looking at my part, you can see that My holes don't go all the way through, which they shouldn't. I cut all the way around the part, and everything is in tolerance. So, with that said, all I would have to do at this point is set my X and my Y 0 on my machine. I would set my Z 0, and then I could simply select execute. And from that point in time, I would hit cycle start, and it would go through and actually start cutting everything. However, I don't have anything set up, and this is a simulator, so it won't work. And all I would have to do is just put this program on my USB and take it out to the machine. Or if you're already on the machine, you can just simply set up your work offsets in your tools and hit cycle start. So again, my name is Aaron Runk with Tulsa Technology Center. I hope this is useful. It is a lot of information. Please watch it a couple times if you have any questions. And thank you again for watching.